Section 2.4. Determine if the given differential equations are exact. Okay, let's see. The first one. For the first one, we need to determine m of x comma y. Well, m of x comma y is that expression multiplying dx. So in this case is y to the third. And then this is part A. And then n of x comma y would be that expression multiplying dy, which is 3x y squared. Then now we're going to find the partial derivative of m respect to y. Remember, when we find partial derivative respect to a variable, the other variable is going to act as a number, as a constant. So the partial derivative of m of y to the third is simply 3y squared. Now, the partial derivative of n respect to x. So when we find the partial derivative of n respect to x, y would be a number. Y is going to act as a number. So what is the derivative or the partial derivative of 3x y squared respect to x? It's going to be 3y squared. Since dm dy is equal to dn dx, okay, then it is exact. Let's see part B. See part B. Part B, m of x comma y. Well, again, m is that expression multiplying dx. dx, the expression in B multiplying dx is x to the second y plus x to the 4 cosine of x. And the n of x comma y is that expression multiplying dy. So that would be negative x to the third. So computing the partial derivative of m respect to y, that would be the partial derivative of m respect to y would be x to the second and just that, because the other term is going to act as a constant. Now, the partial derivative of n respect to x, the partial derivative of n respect to x, the partial derivative of n respect to x is going to be negative 3x to the second. So derivative of m respect to y is not the same as derivative of n respect to x. So the equation, it is not exact. The equation is not exact because the partial derivative of m is not equal to the partial derivative of y. Okay, the partial derivative of m respect to y is not equal to the partial derivative of n respect to x.